Dear student, now we can start our experiment number 3. So what is this experiment number 3? This experiment number 3 is related with large sample test of equality of two population means. See, there are two examples. This is problem number 1, this is problem number 2. So in this problem, we have to test the equality of two population means. So take the first example. Two machines fill milk in 1 point capture cartons. Independent random samples from the two machines produce the following results on net fill weights. So what is given? So given is machine 1 and machine 2, and also the size of the machine, and the mean days and the standard deviation is also known. So machine 1 size is 46, mean is 14.8, and standard deviation is 0.49. For machine 2, the size is 54, mean is 16.2, and standard deviation is 0.76. Now we need to solve this example. How to solve this example? To solve this example, as you know that first we have to write the aim of the experiment. So what is this aim? So aim is to test whether the difference in sample average significant. That is to test H naught mu1 equal to mu2 for the given data. So what is the formula for this? The formula is this. Z is equal to x bar 1 minus x bar 2 divided by square root of sigma 1 square upon n1 plus sigma 2 square divided by n2. And this follows a normal distribution with mean 0 and variance 1. Right? Suppose in some cases where the sigma 1 square and sigma 2 square are same, so that is supposed to be sigma square, then we have to apply this formula. Z is equal to x bar 1 minus x bar 2 divided by sigma upon root 1 upon n1 plus 1 upon n2, which follows normal 0, 1. So what is the procedure? So let x1 is net fill weights by machine 1. What is x2? So that is net fill weights by machine 2. What are given? So n1 is known, x bar 1 is known, sigma 1 is known. N2 is given since there are two cartons. X bar 2 is given and sigma 2 is given. So what is our null hypothesis? The null hypothesis is mu1 equal to mu2 versus the alternative hypothesis. What is the alternative hypothesis in this case? Is mu1 which is not equal to mu2. Right? So what is the formula in this case? The formula is this one. So that means Z is equal to x bar 1 and x bar 2. If you put all the values in this case, what we are getting? So x bar 1 is 14.8. See, the x bar 1 value is 14.8. And what is x bar 2 is 16.2. And what about sigma 1? Sigma 1 is this 0.49. Sigma 2 is this 0.76. What we have to do in this case? We have to fill up all these values and get the calculated value of Z. So what we are getting? So we are getting calculated value of Z is, see, this is the calculated value of Z. Just I will erase this one. What is the calculated value of Z? See, this is the calculated value of Z, that is minus 11.09. But since the value is negative and it is a normal test, so therefore we are converting this to the positive one. So calculate Z is mod Z is equal to 11.0971. Now, so this value should be, that means we need to compare this value with the table Z. What is table Z? So table Z can be obtained such that for two-tailed alternative, the critical region is probability of this value is should be greater than Z alpha by 2 equal to alpha. So what is table Z? So table Z is this value. Which one? It is 1.96. I will show you how we are getting this table value. So for that, see this, the standard normal variate table. And in the standard normal variate table, see, we have to locate the value 0 point, how much? 0.025. See, where is 0.025? So if you see, this is minus 1.96. So that means, see this one, minus 1.9, and this is 0.6. And locate the corresponding value. If you see this one, so this comes out to be 0.025. So that is our value. So this is the area. So this is the area 0.025 we have to locate in the standard normal table. And what is the corresponding Z value? See, it is mentioned here. So this is the value of Z. See, this is the value of Z. So therefore, we have to see this corresponding value in the row and also in the column. So that is minus 1.9, and in this case, this is 0.06. If you add both these, so we are getting this value as minus 1.96. Now, once we are getting this value, we need to compare the corresponding value with the calculated value. And what is the calculated value? The calculated value in this case is 11.09. So compare this, what we are getting? We are getting the value as calculated value of Z is greater than table value of Z. So therefore we reject H0. So reject H0 means what is our conclusion? Our conclusion is there is a significant difference between sample averages. So likewise, we can also solve the second example. So what is the second example? In second example, see what is the second example? See, this one is the second example in which university A and university B are given. The mean standard deviation, population standard deviation, and size of the sample is known. So samples of students were drawn from two universities, and from these weights in kg. So weights are given. These are the average weight. This is the population standard deviation. What we have to do here is we first write down the aim to test the significance of the difference between means, that is to test H0 mu1 equal to mu2 for the given data. What is the formula? So this is the formula, as you know that this is the formula. And what is given in this case? Given is x1 is known, x2, these are the weights. So N1 and N2 both are given. So N1 and N2, N1 is 450, N2 is 150, X bar 1 is 55, X bar 2 is 56, sigma 1 is 11, and sigma 2 is 15. So all these values are given. What we have to do here? We have to put all these values in the equation, in this formula. And what we are getting, since X bar 1 is 55, X bar 2 is 56, sigma 1 square and sigma 2 square, N1 and N2 are given. So put all these values, and finally what we are getting? We are getting the value of Z as minus 0.7518. This is A2. So what is calculated value of Z? Calculated value of Z in this case is 0.75. And we need to compare this calculated value of Z with the table value of Z. So what is the table value? So table value is, again we have to locate the corresponding value, the table value from the statistical table. So the area should be 0.025. See, the area should be 0.025. Where it is? 0.025. See, this is the 0.025. The corresponding value of Z in this case is minus 1.9, and in this case is 0.06. See, this is the intersect point. So the corresponding value of Z now becomes 1.96. Since this is minus 1.96, but the normal distribution is symmetric distribution, so minus 1 point, the area below minus 1.96 is same as the area above 1.96. So therefore, what we are getting in this case? In this case, the calculated value of Z and the table value of Z, if you compare this, so calculated value of Z is 0.75, table value of Z is 1.96. So calculated Z less than table Z except H0. So except H0 means what? There is no significant difference in sample means. Means both the sample means are somewhat same. So likewise, we need to solve all the examples of this course. This is SEC course, that is the statistical test in research. So By this way, we can complete this experiment number 3.